you may or may not be wondering about those coefficients and how you could find them if you don't want to go down the rows of Pascal's triangle to find out what all the values are. Well, there's another way to do it, and that is considering the idea of a factorial. That's the first thing we'd have to think about. The factorial, by definition, is an integer that then has this exclamation point on it, so that is now a math symbol. I'm not saying n. It is n factorial. That is how that's read. And by definition, n factorial is simply if n is 0, you have 1. But if n is any other number, and again, this is for any n that's an integer greater than or equal to 0, then n factorial is simply the value of n times every other value. You subtract 1 from n all the way down to 1 and multiply all those values together. So for example, 1 factorial is just 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. That's it. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. As you can see, these numbers actually get really big really fast. So 7 factorial is actually 5,040. And the idea of factorials is used in a different version of the binomial theorem. So moving on, these are the values for the rows in Pascal's triangle. So those numbers that we see, this c sub k. And what this does is it allows us to take any binomial, raise it to any power, and be able to come up with each term faster. So notice that we have this big parentheses, we have n, we have a k, and this is read as n choose k. And if you end up taking statistics, you'll see that again, typically. So n choose k is how we read that. And as you can see, it simply says take whatever is the value at the top, the n, take its factorial, and then divide that by the k in the denominator, the factorial of that, times n minus k factorial. So for example, 4 choose 2 would be 4 factorial divided by 2 factorial times 4 minus 2 factorial. That's it. So we have 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. You don't have to write the 1 if you don't want, but 2 times 1. And then 4 minus 2 is 2. 2 factorial again, 2 times 1. I realize I just made a very large fraction bar there that I don't need. So let me tighten that up. And then you can simplify any common factors. So I can do this. You'll see that I have 12 divided by 2, which is just 6. So it's just a number. Specifically, it's the binomial coefficient. That's what we're talking about here, the binomial coefficient, the number in front of those terms in using the binomial theorem. So if you want, you can pause if you're kind of with me here on this. You can pause and you can try and see if you can come up with the other values here, these other examples. So we have 5 factorial, that will be 3 factorial, and then you'll notice the difference between 5 and 3 is 2, because 5 minus 3 is 2, so you'll have this, and that's 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 2 times 1. So just multiplying out those factorials, you can see I can simplify some common factors there to get 20 divided by 2, and we get 10. Notice this one, now we're looking at a couple examples here of using n. So we'd have n factorial over 0 factorial, times n minus 0 factorial, which is n factorial. So 0 factorial, remember by definition, is just 1. So you end up with n factorial over n factorial. I don't really need to do anything there. To have something, I'm dividing it by itself. It's just 1. Over here, however, let's see. So I have n factorial. I have 1 factorial. And then I'll have n minus 1 factorial. Now the thing to notice is that n factorial is just n times n minus 1 factorial. Because the first term of n factorial is n times, and then you'd have n minus 1 times n minus 2 times n minus 3, but that's just n minus 1 factorial. And then in the denominator, 1 factorial is 1, and then we have n minus 1 factorial. So you should see what simplifies here. We just get n. The reason that we're doing these is because this is talking essentially about, I don't know if you've noticed, but this one's actually the first term. When we think about the first term of Pascal's triangle, so it's not surprising that it's 1. We saw that on the first beginning of this section. And then, hold on here, when we do n choose 1, notice we get n, and there are some values in Pascal's triangle where that number is the same as the degree that we're raising the binomial to. So that's where that comes from. All right, so now we have n factorial over n factorial times n minus n factorial, which is 0 factorial, which we know is 1. So not surprisingly, n factorial over n factorial is another 1. This is the last term of the Pascal's triangle. So notice we get the 1 there, and of course the sides of the Pascal triangle have 1s. Now, n over n minus 1, so n, I should say n choose n minus 1. So we have n factorial over n minus 1 factorial times n minus 1 factorial, which is n minus n plus 1 factorial, which just leaves us with 1 factorial. So notice, similar, we have n times n minus 1 factorial. I do that so I can simplify it with the n minus 1 factorial in my denominator. Dun, 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 dun. And then that 1 factorial is just 1, so we just have n. So similar to what you have up at the top. These are the terms, the second terms in. That's how you should be thinking about that, your second terms in. Okay, so we're almost there. So here is our second version of the binomial theorem, but all I want you to see is that the only difference we have is that instead of having c sub k, we have n choose k. So this is just another way to think about the coefficients that go in front of each term. However, other than that, what we have here is very much the same as version 1. So in thinking about what this looks like, if we were to multiply it out and do our summations here, we would start out with k being 0. So that would create n choose 0, which if you look back up onto your sheet, we actually already know the coefficient for n choose 0. And we'd have a to the n and b to the 0. But of course, that is just 1. The second term will be n choose 1. You may notice again, we found that one. It is up in our examples from earlier. And then we start off with doing 1 down on our A and 1 degree up on our B. Then we go into n choose 2 and so on and so forth here. So A to the n minus 2, B is going to go up in degrees. So here we have this. And we just keep going like that, you know, until essentially we're done. But we have n choose k, okay, and that's going to be a to the n minus k. That's kind of the general idea here. B to the k, and then the last term, sorry, I'll have to write it right here, will be n choose n. So once, you know, what k is equal to is the same as n, then you have n choose n. You'll notice, again, we have that coefficient. We already did that. That's going to be 1. Not surprisingly, a is going to be to the 0 because n minus n is 0. And you will have b to, of course, the same thing that you had a to in the beginning, b to the n. And we're going to take a look at a couple examples here. We have one right here. So this is find the fourth term. So just one term. If you were to multiply out x minus 2y to the 10th, what would be the fourth term? And what the binomial theorem does is it allows you to do this without actually having to do all that multiplication. You just need to use our binomial theorem here. So the idea would be, in this case, our n here is 10, okay, because that's what we're raising, that's what our power is here. So we've got that, n is 10. And we would also need to be thinking about our k. Now the big thing to understand is that because k is 0, k starts with equaling 0, your fourth term would be k equals 0, k equals 1, k equals 2, k equals 3. So our k is actually 3 because k starts at 0. But now we can come up with our fourth term. Our fourth term will be n choose k, and then times, and give me 1 second here, but I'll do a couple lines, a to the n minus k times b to the k. Now, of course, we have to think about what our a and b are. We also have to think about what the coefficient is, n choose 3. So in our case, notice the a will be x, the b will be the negative 2y. So don't forget that based on the binomial theorem, we want to look at this like this so that we have the correct a and b. So remember that n choose k is going to be n factorial over k factorial times n minus k factorial. This. That will be multiplied by a to the 7th and b to the 3rd. And this is it. I mean, we need to simplify it, but this is it. So 10 factorial, notice, will be, what I'm going to do is do 10 times 9 times 8, and then I'm going to write times 7 factorial because that is the largest factorial I have in the denominator, and I can simplify here. So I'm going to simplify. I still need 3 factorial, which is 3 times 2 times 1. Then we have x to the 7th, and we have a negative 8y cubed. So notice, all right, I'm going to simplify my factorials here. 10, and then I can do more simplifying. So I could simplify this 2 with this 8 to get 4. I could simplify this 3 with this 9 to get 3. So now my denominator is just 1. My numerator is 10 times 3 times 4. So 10 times 3 is 30. 30 times 4 is 120. So I have 120. And then I have negative 8 x to the 7th y cubed. So now I would just need to do negative 8 times 120, and that will be a negative 960 x to the 7th y cubed. So even though that was a lot of work, it is just the fourth term in the drawn out expression that is x minus 2y to the 10th. This is the fourth term in that very long expression. Now, if you want, you could take a moment, you could pause, see if you can find the sixth term in this binomial that's being raised to the 8th power. So we have n to the 8th. Our job is to find the sixth term. So we do have to think about the fact that k starts at 0. So 0, 1, 2, 3, 4, 5 is going to be the sixth term. So k equals 5. Don't forget that. We have our a, which is x squared. Yay, our b is positive. It is y cubed. And then we just set it up. So n, choose k, and then times our a, as we have there. So a to the, and then notice it's going to be n minus k, so 8 minus 5, times our b to the k, like this. So we have 8 factorial divided by 5 factorial times 8 minus 5 factorial, which is 3 factorial. X to 8 minus 5 is 3. So multiplying that squared to the third. And then y cubed to the fifth is y to the 15th. And then we just need to simplify our factorials here. So similarly to the last one, I'll do 8 times 7 times 6 times 5 factorial so that I can simplify the 5 factorial. We've already seen 3 factorial. If you are like, I know that that's 6, go ahead and write 6, that's fine. Because then you can go like this, the 5 factorial simplified, you can simplify the 6's. Just want to make sure I have everything always written out here. But now we just have 8 times 7, so our coefficient will be 56, x to the 6th, y to the 15th. And idea there, again, that that's the 6th term. If you were to take x squared plus y cubed and multiply it by itself 8 times, this would be the 6th term in that expression. And that is section 12.6.